Everybody, this is Unit 3, final review sheet on systems of linear equations. All right, so what I have here is just step by step for each question. So we're going to get into it starting with number 1. You see the two equations, y equals negative x minus 1 and y equals 3x plus 5. And again, you can use it different methods to solve. If you notice, I just set them equal to each other using the equal values method. So I solved for variable x here was equal to negative 1.5. And when you're done, you just want to substitute top or bottom equation. Doesn't matter which one. I chose the bottom. The y equals 3x plus 5. You solve that, and you get y is equal to 0.5. So our solution set is negative 1.5. That's our x value, comma, 0.5, and that is y. Now, a lot of these questions, again, are going to follow the same format where you can use different methods to solve. You can use equal values, where you make both equations equal to each other. You can use substitution, as I'm going to do here in number 2. You can even use like elimination, as we'll look further down, number 3, or multiplication for problem 4. Again, you can use different methods. These are not the only ones that work, but these are just the ones I selected for this video. So let's go into number 2. We have two equations here. And you'll notice I did use substitution for this one because the variable x was by itself already. It says x is equal to negative y plus 4. So since x is already by itself, I just took that and I substituted, as you see here in blue. I just took that part and replaced that blue part, the negative y plus 4, and x. Now I solved, I got y is equal to 2. And again, no matter which method you choose, once you're done, you want to substitute to find the value of the other variable. Again, doesn't matter if you substitute into the top equation or the bottom. As you see, I chose the top, x equals negative y plus 4. When I substituted, I got my answer of 2. So my solution set was 2, comma 2. X and y were both equal to 2. Now again, number 3 and 4, you can use any method. As you see on the left-hand side, I chose elimination for number 3. And the reason I chose that is because if you look at the problem, I already saw that the variable y had opposite signs. On the top was negative y, the bottom was plus y. Those cancel when I add them, so I got x is equal to negative 2. And again, we just take that, substitute into the top or the bottom equation, and I got y was equal to 5, making our solution set negative 2, comma negative 5 for number 3. Now going into number 4, I chose, once again, a different method of multiplication. I multiplied here because I saw the coefficient for x was positive 3 on the top. On the bottom, it said negative x, which we know is negative 1x. So I wanted to get rid of those x's. To do that, I multiplied by a positive 3. If you look to the right, positive 3 times negative x gives me that negative 3x, which is in red. Now my x's cancel. I solve for y. And I got y was equal to negative 3. Again, our last step, once we get the value of one variable, we substitute. In yellow, I substituted there. And I chose the top equation. Again, you can choose top or the bottom, doesn't matter. And I got x is equal to 1. So my solution set for number 4 is positive 1, comma, negative 3. Now, just to review these first 4 we've looked at, remember you can choose any method: elimination, substitution, equal values, multiplication. Again, I just chose one different method for each question just to kind of refresh your memory if you did forget on how to do each one. And also, more or less the best time to use each one. Again, number one, I set them equal since they both have just y equals and y equals. Two, I said substitution because we have the value for x already by itself. Number three, I chose elimination since the y's would cancel immediately. And number four, I chose multiplication since if I multiply, I can eliminate or get rid of my x's right away. Again, you have different options. All right, let's go down to the next section. We have numbers 5 and 6. So number 5, you have a word problem here with two different types of trees, type A and type B. What you want to do is you want to take the information to write two equations. So it says type A is 6 feet tall and grows at a rate of 11 inches per year. So when you write that equation, it's 6 plus 11, and you need the variable x because you're not sure how many years that this tree is growing. Same idea for type B. It says type B is 2 feet tall and grows at a rate of 15 inches per year. So again, y equals 2, which is the starting height, 2 feet. And then it's growing at 15 inches per year. Again, we don't know how many years, so we put x. Number 5, method I chose was setting equal to each other, since again, you see it says y equals for the first equation and y equals for the second. That means that you can make them equal to each other, kind of like number 1. Let me just scroll back up so you see how number 1 both had y equals and y equals. So again, same idea here. Set them equal, solve. X is equal to 1, but that's a mistake if you choose that as the answer. It's not done yet. Because yes, x is equal to 1, but the question is asking how many years will it take for these trees to be the same height? So for that, you want to substitute and again, choose the top or the bottom equation, doesn't matter. I chose the top. And here, when you substitute, you're going to get 17. So in 17 years, the heights will be the same. All right. Okay, so here we go. X is the number of years. It is equal to 1. And when we substitute, we get 17. So number 6, question 6. We have corn, we have pumpkins. First thing you want to do when you have two different things, you want to write a let statement. We covered this many times in our notes. So let, in this case, C, you can use any variable. I just chose C, since C is going to stand for corn. C is going to represent the number of pounds of corn, and the letter P is going to represent the number of pounds of pumpkin. So again, what you want to do after your let statement, you want to also write down the two things you're comparing. So if you notice over here in green, we have number of pounds and number of dollars. The reason for that, you want to label, because if you don't label, what happens a lot of times is we don't know where the numbers go and we end up mixing them up. So if you look at the top, I put C plus P equals 300. Now, we set it up that way because we have a certain amount of pounds of corn and a certain amount of pounds of pumpkin. We don't know how many of each. Problem doesn't tell us. So that's why we just put C plus P. Then we put equals 300. I know that would go at the top because the problem says Marvin's farm, it sold a total of 300 pounds. And if you look on the top, we're comparing the number of pounds. On the bottom equation, notice next to dollars, I even put a dollar sign to kind of help you out. And know that those numbers for dollars have to come on the bottom equation where it says dollars. So the problem says it's 175 per pound of corn. So that's 1.75 C. Problem also says it's 250 per pound of pumpkin. That's why we put plus 2.50 P. And the question also tells us Marvin made $600. So that's why it's equal to $600. Again, notice on the bottom I have dollars, 175, dollars again, 2.50, and dollars again, 600. So when you're doing these linear equations, you want to match up the items or the quantities with each other. So if you notice pounds at the top and second equation has dollars on the bottom. Once you do that, again, you have your different choices. Do you want to substitute, set it equal, eliminate, multiply? Again, your choice, but I do recommend in situations like these just to eliminate by multiplying. So if you look at what I did here, I multiplied by negative 1.75 since, scroll down a little bit, that would eliminate. I'll get rid of my C. So in solving for P, I'm going to see P is equal to 100. That means I have 100 pounds of pumpkins. And then last step, substitute to figure out how many pounds of corn. Again, you can use the top or bottom equation. I chose the top, the C plus P equals 300. When I got my answer, I got 200 pounds of corn. And then on your Google form, how many pounds of each item did he sell? Here's what you want to type in. So Marvin sold 200 pounds of corn and 100 pounds of pumpkin. All right, so there's your answer. I have a few more to go, then we're done. So let's go to number 7. 7 is very similar to number 6, where we have two different things, two different equations. We have comedy movies and we have action movies. So again, you can use any variable you want. I just chose X to represent the cost for each comedy movie and Y for each action movie. Of course, you could use C for comedy and A for action. But whichever variables you choose. This one, it actually does give you both of the equations, x plus 2y equals 200. And then the other equation was 6x plus 6y equals 660. Again, you have different options for what you want to do. And I chose the, if you look in yellow, multiplication method, just because I wanted to get rid of the y's. So if you look over here, it's negative 6y plus 6y, that cancels. And we get 3x equals 60. We divide, and we get x is 20. So that means each comedy movie costs $20. And remember, we're not done. We just take our answer and we substitute. So I just chose to substitute into the first equation, x plus 2y equals 200. And I got y is equal to 90. So each action movie costs $90. So make sure you answer that question. It says, what is the cost for each type of movie? There I put it in black where it says answer. Each comedy movie costs $20 and each action movie costs $90. All right, number 8 is a little similar to that as well. Number 8, I have Yankee candles. Small ones are $15 each and large ones are $20 each. So again, notice I will write my let statement first. We have to make sense of the problem. So let S equal number of small candles sold, and L is going to represent number of large candles sold. Again, you have your option, whichever method you want to choose. I chose multiplication. Just make sure before you start, make sure you label the two items you are comparing so you don't get your numbers mixed up. So on the left-hand side in green, I labeled we have candles on top, and we have dollars on the bottom. Now for candles, it tells us that we're going to sell a total of 20 candles, but it doesn't say how many small candles. That's why I put just S plus, and it doesn't also tell us how many large candles. So I just put L. So S plus L equals, now it did tell us we're selling 20 candles, so I put equals 20. On the bottom, it has dollars. So it said small candles are sold for $15 and large candles are sold for $20. It also says altogether, Yankee Candle received $350. So if you notice, I did put a dollar sign for all of those amounts here, just to remind you, those are dollars, those all go together. So $15 there. So 15S plus, here's $20, 20L equals 350, it's $350. Once your equations are set up, now you want to solve. Again, I did choose multiplication. So I multiplied the top equation by -15, since I wanted to get rid of or eliminate that S. I solve for L, and I get L equals 10. Now I take that, and I substitute in there, and I got S equals 10. For our answer, that means the store sold 10 small candles and 10 large candles. Okay, number 9. In number 9, we have two people went to the movies and they bought bags of popcorn and drinks. So again, first step, you want to write that let statement. So let P equal number of bags of popcorn. And D, let D equal number of drinks. Method I chose was multiplication. The first person bought 3 bags of popcorn and 3 drinks and spent $21. So we put 3P plus 3D equals 21. And second person bought 6 bags of popcorn and 2 drinks, spent a total of $30. So 6P plus 2D equals 30. Once both equations are set up, again, you have different choices. How do you want to solve it? In yellow, if you see, I chose multiplication since I wanted to get rid of the P. So I multiplied the top equation by -2. If you look at the red part, -6P plus +6P would eliminate. And I solve for D. That means each drink would cost $8.25. Remember, we're not done. We take that and we substitute. So again, choose either the top or the bottom equation. I chose the bottom one, 6P plus 2D equals 30. And I got P equals 225. So each bag of popcorn costs $2.25. All right. Last but not least, we have number 10. So we have two equations, y equals 2x plus 1 and y equals 2x plus 5. And we have a graph below. We can use the graph. Unfortunately, if you're on your computer, you can't plot it. But that's okay. We just write the solution. So I actually did graph it for you. But even without graphing, we should know the answer just by looking at the two equations. Now, we see that they have the same slope, which is 2. That means we're going to go up 2 units and to the right 1 unit. But if we look at the last numbers, the y-intercepts, I see +1 for the first equation. I see +5 for the second. So remember, if two equations have the same slope, but different y-intercepts, different starting points, that's going to be no solution. As you see here on the graph, that's the case. And it has to be no solution because they have the same pattern or slope, 2/1, but they're starting at different places. So they're not going to intersect. Okay? Thanks for watching today's video. Make sure you watch it again if you have any questions.